You went up and down. Okay, good.
And the bottom below it was wet, really wet.
Yes, so pretty mucky. What else would you think that the soils, if we have way, what would you think some of the characteristics of those soils might be, other than wet?
Compacted.
Absolutely. Yeah, absolutely compacted. Anything else?
Coloration.
And why would you say that?
Because of anaerobic conditions and it's waterlogged for a good part of the year.
Okay, so those fluctuations in the water table, right? So typically we wouldn't have these saturated conditions in late September, maybe. I don't know what typical is anymore, but usually not. And so we might in those low-lying areas, and we're gonna, after we're finished here, we'll kind of walk across the landscape. There's another pit right behind you. You can see that pile of soil out on the side, and you can probably see that little grayish looking color to the right. And know that
the hot tub.
That's the hot tub. Or the cold tub,
maybe
as
cold
it may
tub
be.
today, yeah. Well, I'll jump in though and get a picture.
Yeah.
So.
That would be great. Yeah. You're in? You're in for it, yeah. Awesome.
Extra credit for you.
Hey, I'm not in charge of grades. So.
Water Week's coming up.
Oh, that's true. Polar bear plunge in the soil pit. I like it. Could do a fundraiser for something. So our landscape position, if you remember, we talked about that little drawing that we had, and the profiles are going to look different as we move across the landscape because of those soil forming factors, and those processes that we talked about are really going to influence that. So the mottled soil, the mottled colors, is from that fluctuation of the water table. As we get closer down to the stream terrace and the floodplain, some of those will just be really in a reduced situation, and maybe more of a hydric soil because of that wetness that's constant, that's there all the time. I was hopeful that we could see some of the profile there so you could really see those color differences, but I think we can maybe pull some auger samples.
I dug a pit.
Huh? You did? Oh, awesome.
It's only about that deep.
Okay.
You hit water.
Awesome. Good. So, but where are we in the landscape right now? Do you remember the name of that landscape position?
Is this the shoulder? Backslope?
Look around.
Summit?
There's a lot of guessing. We have a summit, a shoulder, and a back slope.
Anybody else want to take a gander? Come to consensus?
No. Summit's the consensus, right? Absolutely. So we're at the summit. So our soils at the summit tend to be deeper. They will be. I don't know that we talked about. Did we talk about loess? I don't know that we mentioned loess as a parent material in class. But when we're in a summit position, we typically have parent material that we call residuum, or that residual parent material. It's not really impacted much by movement by gravity or movement by water as some of the other positions are on the landscape. We really just have that residual soil that's really forming in place. But then in Kentucky, we also have a loess deposition, L-O-E-S-S, and that is wind-blown material, typically silt material that's wind-blown and deposited over time on top of that residual parent material, which in central Kentucky is, as you remember, limestone. Absolutely. So we're going to take a look at the at least texture, structure, and color of the Maury pit. So this is the Maury soil, although Steve Lampe calls it Maury/bluegrass.
It's now, they call it bluegrass. They changed the name on it for whatever reason.
So that's just a series, and again, in classification, that's kind of the lowest level classification, I guess, or is soil series. And so we talk about those characteristics. So we'll look at those in the pit and get a little dirty.
A lot dirty.
Yeah, maybe a lot. Some of us may get stuck in there, but at least we do have
I got my truck and a really long rope. We can pull you out, I guess.
Yeah. So, and then we'll start to try to look at the horizons. But before we go in, from where you're standing now, or even if you go over closer to the edge and look into the pit, start to see if you can figure out where we might break those horizons. Where might those soil layers be divided? And what are some, and think about what are some things, the reasons that we might call it a different horizon. So I hear some negotiations. Okay, what do you
Sorry.
say? No, go ahead.
Have it.
Yeah, out loud.
I was saying like the first foot looks pretty dark. So I don't know like soil levels, but I mean,
Okay.
I guess like an O, I guess.
Probably not here because
not
it's
here.
been disturbed. Remember we saw the O typically in a
Did we talk
mature
about this Wednesday?
forest. Yes, we
No.
weren't there once. Yeah. Okay. You're doing good
And
though.
then, like the next 18 inches looks the same. He thought it was different, but
I thought it looks like.
like not the same as the top, but I mean like. it
Okay,
looks
so that would be
different, but, like,
I
another
thought there was a third
horizon.
one that kind of in the middle, this
So-
darker. right
Yeah.
there, too.
3 distinct colors then,
Yeah.
from way out here.
Yeah.
Okay, so what's driving those colors, do you think?
Minerals? The minerals.
Okay, minerals.
Okay, good.
So what mineral would make that sort of reddish? Iron.
No idea.
So when iron is in an oxidized state, what color is it? And when it's in a reduced state, do you know what color it is?
Yes.
It becomes grayish. So, and in some cases in soils, because it's mixed with organic matter, it gets kind of dark. So one of the things that you see, so knowing that iron is in its ferric state or its oxidized state, even though we've had 6 inches of rain in the last few days, do you think this is a drier soil or a wetter soil?
Normally. What is it normally? What is it normally?
Where's the sun?
If the iron has a lot of red and it's, okay, and also think about our landscape position. How's water going to move up here on this ridge or this summit? Is it going to move down, do you think? Look at that soil profile there. Is it going to move across the landscape or through the soil? Right, so you're going to have probably pretty high infiltration right here. So you have movement of soil through here. We'll talk about how rapidly it moves when we get down and get intimate with the soil. And but it's a pretty deep soil profile too. I mean, you go down pretty far before you hit any rock or anything, right? So just looking at it from back here and knowing our landscape position, we know that probably water infiltrates pretty good in this landscape position. We have a deep, relatively oxidized soil. So that tells us a little bit of the story about soil moisture, the fact that we have a nice mineral soil because it's pretty red throughout. Now, why would you think it'd be darker up at the surface?
Organic matter.
Right. So where's that organic matter coming from?
Yeah, fertilizer and
Now, what's that green stuff growing on top of it? Yeah. So the grass, and how deep do you think the grass roots grow in this soil? Really? Okay. We'll take a look at that when we get down in there. So do those roots, do they stay alive always? No. So every year you get sort of like root turnover and dieback, and you get the grass here in a few months will die off, and then you'll have new stuff grow back. And so all of that death and life and the bugs in there are moving it around. And so in that upper part of the horizon where you have a lot of oxidation, it's incorporating that organic matter into the soil. And that's why you're seeing it a little darker there on the surface. Now, why do you think it might be darker down below? You see that you have this nice oxidized area, and then all of a sudden it gets sort of almost the same color as the top.
The nutrients flow through the bottom.
Now that can happen, but not in this soil. There's something called a spodosol where that does happen, but this is not a spodosol. I like where you're thinking then. So Amanda gave you a little hint. She said this soil was residuum. What does that mean again?
Residual.
It's formed from what? What is this soil formed from?
You said it already.
Limestone, right? So that's the rock that's here. How far down do you think we have to go before we hit rock?
Not very far.
Not very far, you're right. So just below where we stopped, you'll start finding big rocks and stuff like that. So that darker area down there might be influenced by that parent material. And in these particular soils, that rock also has a lot of manganese and other minerals that happen to be kind of purplish. So we might pick up some darker colors down below because of the parent material. So we need to go in, like I said, and get intimate with it and sort of sort all these things out. But yeah, from just back here, you can see a lot of, you know, useful information about what's going on in this landscape position. So would this be a good site to maybe grow a corn crop? If the fog wasn't here, you would. Yeah, this would be it's nice, deep, and you know, we're not going to assess how fertile this soil is, but it's very fertile. It's some of the best soil that we have in the state of Kentucky. So it's good for growing row crops, tobacco. We're not too steep here, like a little bit over farther there, we probably wouldn't want to grow tobacco, but we could still grow corn or soybeans or something where we're doing a no-tillage type of agriculture. So this is a really good agricultural soil. It also does a really great job, as you can see, of growing grasses, and one of the reasons that we have the horse industry here in Fayette County and surrounding counties is because of this rolling landscape and these limestone enriched soils. So let's some of you want to grab a spade or two. Got these we can mess around with later.
Grab me a spade.
Eric, Chris brought the manometer so
I know, I'm
we can
excited.
shoot some slopes if he wants to.
Dreams do come true.
They do.
Route me. I did. I got the meadow.
Do we each need a spade?
Sure. Absolutely.
Grab in, folks. Grab a
Sure.
spade, getting dirt.
I got one.
I'm gonna leave this.
You can leave that out here. Yeah.
Just leave this.
You might need it to pull yourself out. But I think you'll be all right.